Let us now multiply matrices. One of the things that is very important to be reminded of whenever we multiply matrices is the possibility of a defined resulting matrix. When we multiply matrices, we need to consider that the sizes will match in such a way that the number of columns for the first described matrix will match to the number of rows to the second. So in short, let's try to identify this first. Matrix A is a 2 by 3 matrix. B is a 2 by 2 matrix. C is a, A is a 3 by 2. Here C is a 2 by 3. It should be number of rows by number of columns. Here, 3 by 3. And E is also a 3 by 3 matrix. Okay? So for AB, this is actually A, 3 by 2 times B, which is a 2 by 2 matrix. It's good. The resulting matrix should be a 3 by 2 matrix, and it should be defined. So when we multiply, listen to this step. We are going to multiply first the rows of A to the columns of your B. The result for that, you multiply 3 by 4 and 0 by 0, and you add them up. Since you are sure that your matrix is a 3 by 2, just like what happens to A. For this process, the result should be here. And then if we're going to multiply the same row of A, the second column of B, the result should be here. So let's try to do that step by step. Again, for the first entry for AB, 3 times 4 is 12, plus 0 times 0 is 0, 12 plus 0, 12. Okay? So you might want to do it step by step. Then 3 times negative 1 is negative 3, 0 times 3 is 0, negative 3 plus 0, negative 3. Next would be this row against this column. Same process. Negative 1 times 4 is negative 4. 2 times 0 is 0. So I have here negative 4. Next, the same row but the second column. Negative 1 times negative 1 is positive 1. 2 times 2 is 4. 1 plus 4, 5. And for the last, 1 times 4 is 4, 1 times 0 is 0, 4 plus 0 is 4. And then, 1 times negative 1 is negative 1, 1 times 2 is 2, negative 1 plus 2, positive 1. This is the result for AB. And as you can see, 3 by 2, that complies with our standard. Next is thrice E times D. So first, of course, we can try to check the resulting matrix if it's defined. E is a 3 by 3. Even if you're going to multiply a scalar multiple of 3, it will not change the size. Times D, which is also 3 by 3. So the result is defined, and it should be a 3 by 3 matrix. Let's find out. But first, let's have thrice E. So all the entries in E will be multiplied by 3. So from here until here. So we will have 18, 3, 9, negative 3, 3, 6, 12, 3, and 9. And we are going to multiply this to D. Okay? So the same process earlier. Multiply this to the first column. 18 times 1, 18. And minus 3 is 15. Plus 27 is 42. So we'll have 3E times D. Okay. Again, why do we start with this? Because per grouping symbol, we start with that before multiplying to D. So the first entry is 42. Next is to multiply the same row to this, to this column here. So 18 times 5, if I'm correct, is 90. 3 times 0 is 0. 9 times 2 is 18. 90 plus 18, 108. You might want to use as well calculators here. It's up to you if you would like to. Next, the same row to this column. 18 times 2 is 36. Then plus 3 is 39. 4 times 9 is 36. So 36 plus 39 is 72 plus 3, 75. Next, this row to this column. Negative 3 times 1 is negative 3. We also have another negative 3, so that's negative 6 already. 6 times 3 is 18. Negative 6 and 18. I have positive 12. Pardon about the, what they call this one. I'm in pace with my computation with regards to multiplication. Hopefully you are following. Negative 3 times 5 for the second is negative 15. This becomes 0. So I still have negative 15. Then 6 times 2 is 12. So negative 15. And then I have 12. So I have 3. Sorry, negative 3. Next, for the same row to the last, negative 3 times 2 is negative 6. But I have positive 3, so I have negative 3. Then 6 times 4 is 24. 24, then negative 3, I have positive 21. Next, for the last, 12 times here, this row times that. I have 12 minus 3 is 9. 9 times 3 is 27 times 9, plus 9 rather, 36. Next, 12 times 5 is 60. Because of this, the next would be 0. 9 times 2 is 18. 18 plus 60, 70. And finally, 12 times 2 is 24. Plus 3, 25. Plus 36. 25 plus 36 is 60. 25. Again, let's do it again. 12 times 2 is 24. No, 27. Yeah, 24 plus 3 is 27. And plus 36. So you have 63. This is the result for the second. Now let's continue with the next. I already have the AB earlier. I'm going to multiply it with C. AB is a 3 by 2 matrix. And C is a 2 by 3 matrix. So we are assuming to have, or we are hoping to have, a 3 by 3 matrix here. So AB, multiply this first two rows here. So 12 times 1 is 12, and then you have negative 9. The result would be 3. Next, the same row to this. 12 times 4 is 48, then minus 3, 45. Then the same here. 12 times 2 is 24, minus 15. 24 minus 15 is I have 9. Next, this row here. So pardon if I am scribbling on the previous answer. Hopefully you were able to understand the previous answer. Negative 4 times 1 is negative 4. Then 15, I have positive 11. Then negative 4 times 4 is negative 16. And then I have 5. So I have negative 11. Then negative 4 times 2 is negative 8. Then 25. Negative 8, 25. I have 17. Finally, for the last, 4 times 1 is 4 plus 3, 7. Then 4 times 4 is 16 plus 1, 17. And 4 times 2 is 8 plus 5, 13. So we're already halfway. So let's simply continue. But first, let's solve for BC. BC. B is a 2 by 2 matrix times C, which is 2 by 3. So we expect a result which is a 2 by 3 matrix. So we'll multiply BC first before multiplying the result to A. So B, here's B, this row. And then multiply this column. 4 times 1, again this one. I might change the color if you would like to. This one here and this one here. 4 times 1 is 4. And then negative 1 times 3 is negative 3. 4 minus 3, 1. I have 1. Next, same row to this. 4 times 4 is 16. Then negative 1. I have positive 15. Next, still the same row, pardon. Still the same row, but to this, 4 times 2 is 8. Negative 1 times 5 is negative 5. So 8 minus 5, I have 3. Then for the second, you have here 0 minus 1 is 0, 2 plus 2 times 3 is 6. Next to this here, so this is 0, so I have 2, and this will be 0 as well, so I have 10. This is to be multiplied with a, but take note of the arrangement. It's a times BC, because if you are to interchange that, take note that BC is 2 by 3. Okay, and then yeah, you can still get a defined result, but it will be different answer, because if it's BC times A, you will have BC times A 2 by 2 matrix. But since it's A, which is 3 by 2 times BC 2 by 3, the result should be a 3 by 3 matrix. Okay, so pardon my handwriting. Let's start with A. This one here. Multiply to here. 3 times 1 is 3 times plus 0, so I have 3. Next, we multiply that here, so the second term is still 0, so only 3 times 15, 45. Then, 3 times 3 only 9, because 10 times 0 is 0. Next, negative 1 and 2 here. Negative 1 and 1 is negative 1, 2 times 6 is 12, and then you have negative 1 earlier, 11. Multiply the same here. Negative 1 and 15 is negative 15. 2 times 2 is 4. Negative 15 and 4, negative 11. Next, the same, but here, so you'll have negative 1 times 3 is negative 3. 2 times 10 is 20, and then negative 3, positive 17. Pardon, change it back to black. And then next, you have this last, not last, here, 1 times 1. So simply add 1 and 6, you'll have 7, and then 15 and 2, 17, 10 and 3, or 3 and 10, 13. This is the result for the fourth. Now notice the result of this operation and this operation here. They have the same results. This is actually under the associative law of multiplication. So they are just the same. Now let's proceed to the fifth one, CD. C. So C, we'll start with CD first. CD. So C is a 2 by 3 matrix, and D is a 3 by 3 matrix. So we expect to have a resulting matrix, a defined matrix, which is 2 by 3. Okay. So let's start with CD first before multiplying it to E. We'll start with a column. This column here. This column here. Multiply to this column. So 1 times 1 is 1. 4 times negative 1 is negative 4. So 1, negative 4, I have negative 3. And 2 and 6. So I have the resulting, which is just, I believe, 3. Right? So again, let's do it again. We have 1 times 1 is 1. 4 times here is negative 4, so I have negative 3. Positive 6, I have positive 3. Pardon. I have positive 3. Next, the same, multiply to the second. 1 times 5 is 5, 4 times 0 is 0, so I still have 5. 2 times 2, I have 4, plus 5, I have 9. Next, the same row to this area here. So 1 times 2 is 2, 4 times 1 is 4, so I have 2 earlier, that's 6 already. Then 2 times 4 is 8, plus 6, you have 14. 14. Okay? The next, you'll have this, second row. Because the resulting matrix is 2 by 3. So 3 times 1 is a 3, minus 1 is 2, plus 15, I have 70. Next, we have 3 times 5 is 15, that's 0, another 10, 15 and 10, sorry for that, that's 25. Then, for the last, I have 3 times 2 is 6. 1 times 1 is 1, 7. And 20, so you have 27. So the result is 27. This is the matrix of the fifth item. Now for the last item, let's try to check whether it's defined or not. Let's have BA. B is a 2 by 2. 2 by 2 matrix. But A is a 3 by 2 matrix. So this is why I mentioned earlier it is very important for you to check, because you might waste some time, because no matter what the structure or the entries of matrix C is, since the first item is undefined, it makes the entire expression undefined. So this is all about matrix operations, specifically on multiplication. We might have a separate video for this, including concepts on transposes. So thank you very much for watching.